In the previous videos, we had learned about the periodic trends and properties of the elements with respect to various physical properties. Chemical properties are also related to the periodic table in various ways. There are things like lanthanoid contraction, diagonal relationships, inert pair effects, and etc. I think we'll be discussing most of these in the coming chapters when we talk about individual groups. But in this chapter, we'll be discussing about the valency and or oxidation states and something called as anomalous behavior or diagonal relationship. Now, valency is the combining capacity. I think that's the definition we all have learned. So the valence electrons are the ones which are present in the outermost shell of the atom, and that in turn will determine the valency of the element. So valency is basically the number of electrons in the outermost shell, or 8 minus the number of electrons in the outermost shell. I think in grade 9 we had learned you learned about the valency and what is the nature of the atom. Does it lose electrons? Does it gain electrons? All of that. So the oxidation state is generally based on the state, or rather the charge, that is acquired by the atom. To clarify this, let's look at two compounds. Here you have oxygen fluoride, and here you have sodium oxide. Now, fluorine is the most electronegative element in the periodic table. So, it will tend to gain electrons. So, we know that this particular atom is not going to lose electrons. So what happens is the oxygen atom will share its electron with fluorine, both these atoms of fluorine. And so fluorine will have a -1 as its oxidation state, whereas because oxygen is bound to 2 atoms of fluorine, oxygen has a +2 as its oxidation state. Now this is because it has a 2s2 shell, and it shares 2 electrons with fluorine atom, and so it shows a +2 oxidation state. Sodium oxide, on the other hand, oxygen is more electronegative than sodium, and so sodium will lose one of its electron and gives it to oxygen, and so it gains a +1 oxidation state, whereas oxygen is accepting 2 electrons, so it'll show the oxidation state of minus, because it is accepting 2 electrons from 2 atoms of sodium. So oxidation state depends upon the acceptance or the removal of the electron. If it's accepting an electron, it will have a negative oxidation state. If it is losing an electron, it will have a positive oxidation state. So here oxygen is showing +2 oxidation state, whereas here the oxygen atom showed -2 oxidation state. So this is in turn dependent upon the atom that particular element is bound to. Now, here, if you see, you have the group 1, 2, 3, 13, 14, 15. The number of valence electrons varies with respect to which group it is present in. And based on that, the valency also varies. So 1, 2, 3, 4 is the valency of these elements, which means they have the tendency to lose 1, 2, 3, and 4 electrons, whereas 3, 5, 2, 6, 1, 7, and 0, 8 means 3 means it has a tendency to gain 3 electrons or lose 5 electrons, gain 2 electrons, lose 6 electrons, gain 1 electron, lose 7 electrons, gain 0, lose 8. So that's the basic idea behind valency we had learned about. Now, if you see across the period, so this is actually a little different version of the periodic table, but it actually shows us the various oxidation states of and the hydrides and the oxides of that particular group. Now, if you notice across the period, the valency decreases it increases from 1 to 4 and then decreases to 0. So it becomes 1, 2, 3, and 4, and then goes back to 3, 2, 1, and 0. And down the group, there will be no change in valency or the oxidation state because each group will have the same number of electrons in the outermost shell. So they have the same valency. That's the characteristic of a group. Now, here, if you see, you have various formulae of hydrides and uh, oxides of various elements. So with that, I believe we are done with the valency and oxidation states. So basically, valency is the tendency to lose or gain electrons based on its or the combining capacity of an atom. Oxidation state is generally observed when an atom binds to an element or forms a bond, and based on the characteristic of the other element, we can figure out the oxidation state. So in our examples, we had learned oxygen difluoride and sodium oxide. Here, oxygen showed two different oxidation states. When it was bound to fluorine, it showed a +2 oxidation state because fluorine is more electronegative than oxygen. Whereas when it was bound to sodium, it showed a more negative or -2 oxidation state because it is more electronegative than sodium. Across the period, the valency will increase to 4 and then it goes back down. And down the group, because the valence electrons are going to be the same, uh, there'll be no change in valency or oxidation state. One very important thing I wanted to say was, so in the periodic table, our elements of group for 1 and 2 will show only one oxidation state because they either have a tendency to lose one electron or lose two electrons. But the elements in the D block and especially the F block, both of these groups, both of these sets of atoms will show a different set, various number of oxidation states. So iron will show two oxidation states, and this is in turn because of the d orbital which comes in between. We will be learning about that in detail when we talk about d block elements. So we are done with the valency and oxidation states. In the next video, we will be discussing about the anomalous behavior.